This video centers on a surprising phenomena exhibited between a pop can and a charged sheet of styrofoam. This video made as my project in connection with the Carlton Summer Teaching Institute. And the focus of that institute was a new 2-year physics program called Physics 1 and 2. This will replace AP Physics B, which is in its last year. The Physics 1 and 2 are defined around 7 so-called big ideas. These big ideas help students have a broad understanding of the physical world. In this video today, our emphasis would be on the first big idea. First big idea has to do with properties. And the first big idea says that all systems and objects have properties such as mass and charge, and also have internal structure. We're especially looking at charge today. After we introduce that, this activity today, there'll be some enduring understanding that we will look at. And in the enduring understanding, once again, charge is a property of a system or an object, and that affects its interactions with other systems or objects that also have charge. That's the enduring understanding, this interaction between objects or systems that have charge. Now, under that enduring understanding is essential knowledge that we'll be looking for. Essential knowledge is the idea that there are only 2 kinds of charge, and even neutral objects have charge, equal amounts of positive and negative charge. The only exceptions being some fundamental particles have no charge. Today, this is a 1-day lesson, and the students will be aware of this focus. This is the focus for the entire day. I can predict and explain what happens after a charged sheet of styrofoam touches a pop can that is lying on the floor. In this case, it'll be lying at my driveway. By the way, this driveway does tip down, so that might affect what I'm going to demonstrate. I'll start with the pop can, maybe go to the large can also. Anyway, I can predict and explain what happens after a charged sheet of styrofoam touches a pop can lying on the floor. Before they do that, I would have a session to review prior knowledge. And what I like to use are clickers. And I use multiple choice questions, very brief questions, and they anonymously can give their answers, A, B, C, D, or E. What I try to look for is misconceptions that we can head off on things like charge, positive and negative charge, how we charge things either by induction or contact or polarization. And after I've seen that they're solid on these things, after they've had chance, now they've given chance to elaborate on this, not just answer A, B, C, D, they can defend their answer. This is for participation, so there is a permanent record of this clicker event. And what I look for there is not whether their answers are right or wrong, but whether they participated. Now, after this session, after we've reviewed their prior knowledge, and of course it's a formative assessment. I should say that we stop, especially at any point where there seems to be some misunderstanding or confusion. We'll spend more time on it, more questions on it. After we've done this formative assessment session, then the students in groups of 4, working with whiteboards, will come to a consensus of what they think will happen when a charged sheet of styrofoam is touched against a pop can. Not just prediction, but they must explain it. And they must display on their whiteboard to the rest of the class. They can verbalize it also rather than just show it if they choose to do so. Depending on how many groups there are, we don't want to spend all our time on that. After they've given their answers, they're given each group the material, styrofoam, some wool, pop can, to try this experiment. And they're told that if their prediction is not correct, and I expect a lot of them will be wrong on this, it's kind of surprising. That's what's fun about this. It's not in any of the books, so they can't read about it ahead of time. Even some physics teachers will be surprised by the results. After they've tried it, they can perhaps be smugly confident that their predictions are right, but we'll also review their explanations. If not correct, they can adjust their hypotheses. These whiteboards are numbered, so at the end they will turn these whiteboards into me for an assessment. Our final assessment will of course be for the week would be a written test. But at any rate, I want to just demonstrate now what actually happens. It's kind of surprising. I have styrofoam and the can, and I think I might want to check my focus to see whether I can catch this with that camera. Okay, I've got a pop can. I'll lay it against this weed in the driveway. Good thing we have a bit of wind here. As you can see, the pop can is strongly pulled along by the styrofoam. And what is happening here, one has to think about conductors and insulators, and that would have been part of our prior knowledge review. And some students think, well, the charge along the styrofoam would be shared with the can. The negative charge in the styrofoam would be shared with the can. Therefore, they would be mutually repulsive. But they forget that this is an insulator. The charge along the insulator does not travel to the can. It's not the nature how charges move on an insulator. And it only touches the can in a very minimal spot. And so what's really happening is not a sharing of charge, but an induction. The negative charge on here repels negative charge on the can to the other side. In this case, the charge property shared by electrons. So those electrons, those valence electrons moving to the other side of the can. Now, there'll be a limit because not all the electrons want to go to the other side, because the positive remaining, the imbalanced positive charge remaining on the can will also have its pullback on those electrons. Some charge may be shared with the surface below if it's a conducting surface, but not a lot, because here again the positive charge of the can will tend to hold on to those. Now I have another can just for the fun of it. It's a bigger can. I'll try that one. And whoops, I'm having trouble with this can has a little stickiness on it where I pulled the label off, sticking to my start line. Well, as once again, this for drainage, this driveway does go downhill away from me. Let's try the larger can. And see, even the larger can is pulled by this. You can see left to its own, this can would roll down. So I'm working against gravity. I'm working against gravity when I pull that large can. It'd be kind of fun to see how big a can I could pull. Working against not just the can but gravity and the wind also. With the pop can being much lighter, it's demonstrably easier to see. Well, that's it. Thank you.